Yeah, I think my screen is visible to you all guys. Yeah, okay. So these are today's topics, recursions and recursive relations, substitution method, how to solve this recurrence relation, we wanna see. Then we have a tree ADT, tree ADT, the terminologies of trees, and then a small intro to binary trees. So okay, after these tomorrow, Harish Rajan and Angel and Adam cover the rest of these topics of Unit 3. So as I said, last class I couldn't like take properly, so I thought of retaking these topics. Yeah, all right. So let's start. Okay, recursions. What are recursions first? Okay, recursion refers to reducing a problem into a smaller instance. Okay, these are like just recursion. Like you have a bigger problem, you break down into small chunks. You solve the smaller chunks, and then you add it up entirely. So that's what you call recursions. It's a method of solving problem where the solution depends on smaller instances, the same problem. Okay. So yeah, for example, okay. For example, let's have an example like you search a dictionary. Okay, how do you start searching a dictionary? You open a random page in the middle, right? Open the random page in the middle, and then search for either you search for left hand side, left part of the dictionary, left part of the dictionary, or you search the right part of the dictionary. Okay, and you keep on searching the same dictionary over and over. So you either find the word or not. You either find the word or not. Okay, it's either present in the dictionary or not. All right. So recursions, we have two main steps. One is a base step. That will be our end of our recursion problem, and then one is a recursive step actually. The base case is the simplest solution. This is where the recursion stops usually. Usually it stops, and recursive step is that's a step which call itself the function calls itself. Yeah. So these are the two steps. And one more thing, a lot of you might have like a difference between a lot of you might have confusion between loops and recursion. Okay, a loop is not a recursion. Loop it's the same block of code. Okay, it's the same block of code. It repeats each time, each and every time until a specific condition is met. That's what we call a loop. A loop has a constant memory. Okay, loop does not uses extra memory. Just a second, guys. 1 minute. Yeah. So sorry, that was a call. All right. Yeah. So where are recursions? Yeah. Okay. So difference between loops and recursions. Yeah. So loops is the same. It's the same block of code which repeats itself each time. It doesn't use extra memory. When you code, it doesn't use extra memory. It just calls itself again and again. Uh, so when the condition is met, it just terminates. It comes out of the loop. Okay, that's a loop. Now, what is a recursion? A recursion is again a repetition but it's a block of function. It's a block of function which calls itself repeatedly. Okay, with each time with different inputs. See, just this is a major difference here. In recursion, it's a block of code with each time with different input. Okay, so yeah, that is recursion, and also recursion uses an extra memory. It uses some memory called stack memory. We'll see in what's the stack memory function called stack, and then it terminates when the base case is reached. So when the base case, we have two cases. One is a base case, one is a recursive step. So when the we terminate when the base case is reached, unlike loop. So yeah, so these are the like major differences between loops and recursions. Okay, we'll see an example of recursion, how recursion is involved in computer science, right? So let me share my screen. Okay, just right. I hope you can see my screen. All right. So uh, okay, we'll do sum of n natural numbers. Okay. So our code goes like this. We have our main function over here. And then in main, I'm just writing algorithm. It's not entire code. So if 1 second, guys. All right. So, yeah. So if n is equal to 1, return 1 or n or 1. Yeah, it doesn't matter. And else part comes here. Return uh, n plus f of n minus 1. Okay, wow. So like just for simplicity, I'm calling this our function as f of n. All right. So this is our algorithm for a sum of n natural numbers. Now what I'll do is I'll draw a stack over here. Just draw a stack. This is my stack. Now, yeah, we'll just break down into some simpler problems. So far, we'll consider for n equal to 3 maybe. N equal to 3. So first our control goes over inside the main function. Yeah, so our main function hasn't been so once the rules of this stack are just it's just very simple. So when the function gets executed, you pop out of the stack, you pop the function out of the stack. When the function hasn't been completed, you just push it inside. Okay, so I'm entering inside main. Main function has not been completed yet, so I'm pushing it inside. My main function is here. Okay, wow. Yeah. Now n is not equal to 3, so this gives an if part, and now else it enters into else part. Else part is n plus f of n minus 1. Okay, so now this f it calls itself, right, with a different input. Now n is equal to n is 3 here, so I'll write 3 plus f of n minus 1, which is nothing but f of 2. Okay, so this f of 2 Again, I'm just changing the input now. We have, now I have ns2. When I have ns2, this again it calls itself n is not equal to 1, so it's skips this if part, else goes into else part, and then ns2 now, which will give me 2 plus f of n f of 1 again, right? See, f of 2 has not been hasn't been executed successfully, so it just calls itself. Adinu mudiyala, adinu execute avala. So I'm just pushing it inside the stack, f of 2. All right. Yeah. So this is nothing but this is my f of 3. That's what I want. Okay. Now f of 1, 2 plus f of 1. F of 1, n is equal to 1. Yeah, now we reached our base step. This is our base step of this algorithm. I reached our base step, return once. So 2 plus I have my value of f of 1, just returns 1. Okay, wow. So 2 plus 1 is nothing but 3. I've got my this 3 is nothing but I'm a value of f of 2 over here. I've got my value of f of 2. So since I got my value of f of 2, the f of 2 function has been called, has been executed successfully. So I'll pop it out of my stack. Okay, wow. Yeah. So I have got my f of 2 value. So f of 2 is nothing but 3 plus 3. This is nothing but 6. All right. F of 3 is equal to 6 now. I got my value of f of 3 for n equal to 3. That's what I want. So that's the other than the end of the main program there. So that's what I want. That's my wanted value. So I'll just pop main function out of the stack. Right. Yeah. So this is how recursion works. This is how recursion works for sum of n natural numbers. It's pretty simple actually. Yeah. Okay. Now we'll do for n equal to maybe 5. Yeah. Okay. 5 will do. Okay. So yeah, we have n equal to 5. This is our input, initial input. N is not equal to 1, so it enters else part. Okay, first I'll push my main inside my stack. Main hasn't been executed, so I pushed my main inside my stack, and n is equal to 5. So I need f of 5, right? F of 5 தான் எனக்கு வேணும். அதுதான் என்னோட goal. So f of 5 தான் call பண்ணியிருக்கேன், which is not yet, which hasn't been executed. So I'll push f of 5 inside. I have my f of 5 called, which has not been executed, and f of 5 is calling n plus f of n minus 1. All right, n வந்து இங்க 5 plus f of n minus 1 f of 4. All right, f of 5 is calling f5 plus f of 4. Again, f of 4 calls f of now here 4 plus f of 4 calls for f of 3. Okay, wow. My f of 4 hasn't been completed. I'm pushing it inside the stack. F of 4. And again, f of 3 calls 3 n plus f of 2. Again, f of 2 calls 2 plus f of 1. My f of 3 and 2 hasn't been called. F of 3 and then f of 2. All right. Yeah. Okay. Now f of 1 not a value எனக்கு தெரியும், because this is our base step. And it has reached our base step, and it returns to 1. F of 1 is nothing but 1. So I've got my value of f of 2 here. So 2 plus 1 is 3. Okay, wow. Right. Yeah. So f of 1 not a value, 1 is, so 2 plus 1, 3. F of 2, I got my value of f of 2 over here. So which is nothing but, now this 3 plus, I want 3 plus f of 2 for f of 3. Okay, wow. So 3 plus f of 2 is nothing but, now this is 3. 3 plus 3, 6. Okay, wow. Correct. 3 plus 3, 6. I got my f of 2 value. F of 2 has been executed successfully. So I'll pop f of 2 out of my stack. All right. I have 6 over here. My f of 3 value is nothing but 6. My f of 3 value is nothing but 6. F of 3 successfully executed. 4 plus 6, which is 10. I have 10. Again, this is my 10 is my value of f of 4. Okay, so f of 4 I've got. I'll pop f of 4 out of my stack. This is 10. And 5 plus 10, which is 15. 15 is my value of my f of 5. F of 5 முடிஞ்சிருச்சு. I'll just pop it out of this my stack. And I've got my value of f of 5, which is 15. அவ்வளவுதான். So this is how recursion works. Again, f of 15 is my goal. So our main function comes to an end. I'll again pop it out of the stack. அவ்வளவுதான். So our recursive function ends when the stack is empty. This stack over here, like this stack is nothing but our function call stack. Function call stack. This is called function call stack because the name is itself because whenever a function is called, it just gets stacked inside the stacked inside. So whenever it gets completed, it just pops out of this. அவ்வளவுதான். So this is function call stack. Right. We'll do one more example. Uh, we'll do for Fibonacci sequence. That'll be interesting. A little more tricky than this. This is straightforward actually. Okay. Let me write down the algorithm of Fibonacci sequence. Okay. If n is equal to 1 or n is equal to 0, return n, right? Else return f of n minus 1 plus f of n minus 2. Okay, so this is my algorithm of Fibonacci sequence. Okay, so again, I'll draw a stack. I have my function call stack over here. So we'll do for n equal to maybe again, okay, 4. We'll do for n equal to 4. So all right, so n equal to 4. So if again my main function goes inside the stack first. It has been completed. So f of 4, right? F of 4 and that's my goal. அதுவும் இன்னும் முடியல. F of 4 goes inside. Now n is neither 0 or 1, so it goes to else part. Else is f of n minus 1 plus f of n minus 2. All right. I have my f of 4, which calls for two functions simultaneously. Okay. Simultaneously, it calls f of 3 and it calls f of 2. All right. Okay, so f of 3. Now my input n value is my input n value is 3. N is 3 over here. So again, n f of 3 calls two functions. Okay, f of 4 is f of 3 hasn't been completed. It calls itself. I then execute all. So f of 3 inside my stack goes inside my stack. Now f of 3 will call two functions, which is f of 2 and f of 1. Okay. F of 2 and f of 1. Okay. Now again, f of 2 calls two functions. F of 2 is not my base condition. N is neither 1 or 0. So it will call two functions, just f of 1 and f of 0 calls. My f of 2 also goes inside. Okay. Uh, All right, perfect. So f of 1 and f of 0, they are my base conditions. Okay. So if n is 1, it returns 1. All right. If n is 0, it returns 0. All right. So I got my value of f of 2. Okay. F of 2 is nothing but 1 plus 0, which is 1. Okay. F of 2 is completed successfully. So I'll pop it out of my stack, function called stack. And I have f of 1. F of 1 is again a base condition. It returns 1. Okay. So 1 plus 1, f of 3. I got my value of f of 3. F of 3 is nothing but 2 over here. 1 plus 1, 2. F of 3 is also completed. I'm popping it out of the stack. And I have f of 2. F of 2 calls two functions, f of 1 and f of 0. These two are my base conditions. So f of 1 is 1, f of 0 is 0. When I add them, I'll get f of 2. F of 2 is nothing but 1 again. I got my value of f of 2. And now I have f of 4. So f of 4 is nothing but 2 plus 1, which is 3. Okay. I got my value of f of 4. That's 3. Yeah, since f of 4 is my goal, I've reached my end of my main function, so I'll pop it out of the stack. So let's check f of 4 3 then. Let's check 0 1. Yeah, f of 4 is 0 1 2 3 4. Yeah, f of n equal to 4. Fibonacci sequence gives 3. All right. F of 4 is 3. Yeah, so this is pretty much recursion. This is how you track recursion and algorithm using an algorithm. So we've done Fibonacci sequence, we have done sum of n natural numbers. All right, what's next? What do we have next? Mm, okay, yeah, analysis. So since how do you analyze this recursive? How do you analyze the recursions? I mean, like, how do you find the how do you find the step count of this recursive recursive functions? I mean, you actually can't find recursive this you can find, but if you go with the direct method, like having they were like you have to call it, so it just calls again and again. It will be so complex if you go with the direct method. There's a way called step substitution method. Okay, first I'll explain what's a recurrence relations. Okay. Right. Yeah. Okay. First, explain what's a recurrence relations. Mm. Okay. What's a okay? Let me have a sequence like 3, 6, 9, 12, 15, 18, so on. Okay. Wow, this is nothing but three table. Okay. So how do I generalize this and write in terms of one single expression? You can write it like an is equal to an is my term. An is equal to 3 power n. Sorry, 3n. Correct? Okay. Or we'll take a simpler example. Okay. We'll take a much simpler example. We have a 3 square. We have 3 cube, 3 power 4, so on. Okay. So this is my sequence. How do you generalize this and write? An an is equal to 3 power n. Correct? So this is my generalized equation. one of my general easy equation. எப்படின்னா like I want a3. What for what value of n I get a3? Just plug in n equal to 3 and you get a3, right? A3 is nothing but 3 power 3. All right. I want a power 5. What's a power 5? Put n as 5, you'll get a power 5. Okay. A power 5, okay. Give me a power 100. That's 3 power 100. All right, easy. Yeah. Direct, if you plug in n value, you'll get a nth term. Okay. But this is not a okay. This is something called sequence relation. Okay, well, this is a relation of sequence, direct relation. This expression comes when you study sequence and series. On the topic படிக்கும்போது you'll study about this. But you want recurrence relation. Okay, what's recurrence relation? As I said, recurrence involves calling itself. It depends on its previous terms. All right. So this in the idea expression, I can write it another way. An is equal to 3 into an minus 1. Correct? I can write it in the same way. This both are same. See, if I want, uh, given that, okay, given I have to specify as base step condition. Base step condition given that a0 is equal to 1. This will be given to you. Using this, you can find whatever a nth term you want. But it won't be easy as like this. See, if I want a5, I have when I put n as 5 over here, this is 3 into a power 4. But I don't know what's a4. So I have to find a4 again. A4 I'll again put n as 4 and get a3 into a power 3. Sorry, 3 into a3. And again, I don't know what's a3. So it gets keep on repeating till I reach a0. A0 வந்துருச்சுன்னா I don't know what's the value of A0, but so that would be given over the question. A0 is my 1. So if I know A0, I'll find A1. And if I know A1, I'll find A2, and then A3 and A4 and then A5. Okay. So I need my previous values of AN so that I can reach my goal. Correct? So it's not as simple as this, as simple as this equation. Now, so this is what I call a recurrence relation. See, it calls itself. If you want A4, you need A3. If you want A3, you need A8. It calls itself. So this is what I call a recurrence relation. All right. Now, in the recurrence relation, Vachida, we are gonna solve step count of time. We are gonna find time complexity of our functions, recursive functions. Okay, you can't do it in a straightforward method. It'd be too complex. So this recursive function relations which we're gonna solve. Okay, we'll see how it is. Guys, when the meeting ends, I'll reshare the link. You can join it there because we only have 40 minutes for this meeting. Okay. So other example எடுத்துக்கலாம். We'll have same example, the sum of natural numbers. So we will start by finding the step count of finding the time complexity of the base step. Okay, what? That's our initial step. Here our base step is nothing but f of f of 1 is our base step. Okay, n is equal to 1, return 1. We'll find the step count for this. If n is okay, this is nothing but 1 just. There 1 more now. Return, it says it's nothing else. It just checks if it is 1 or not, and then returns 1. You don't have return. You don't have time step count. If okay, you have 1. And now else, there's else part over here. Else part calls itself. Okay, fine. Let me elaborate this. Else. Okay. So for t of 1, t is my function. T of 1, I have my step count as 1. I know. Yeah, this is my base step cost, base cost. Okay, I need for T of n. ஏன்னா நான் n தான் input கொடுக்குறேன். I need it for n natural numbers. So okay, first I either okay T of n, that function as it calls itself, that function as a recursive step. It again calls itself with T of n minus 1, correct? It calls with n minus 1 as a input again itself. I know that எனக்கு அவ்வளவு தெரியும். Plus 1 from, I'll add 1 for with this base step cost. I have the base step cost from and the initial part of the code, so I'll add 1 over here. So this is my now this is my recursive relation over here for my sum of n natural numbers. Okay, but I don't know what's T of n minus 1 and n T of n minus 1 ne vechirken. So T of what? So to find T of n minus 1, now I'll substitute n minus 1 instead of n over here in in the same equation. So I'll get T of n minus 1 is n minus 2 plus 1. Okay. Guys, the meeting is gonna end. I'll reshare the link. Okay. Again, I don't know what's the value of n minus 2, T of n minus 2. T of n minus 2 is equal to T of n minus 2 minus 1, which is T of n minus 3 plus 1. Okay, wow. I can go on like this. I can go on like this. That for T of n minus for some k or maybe for some I integer, that will give me T of n minus. Yeah, I have 1 over here, I get 2. So I'm just following the same pattern. So if I follow the same pattern, 1 இங்க இருக்கு, இங்க 2. LHSல 2 இருக்கு, I have 3. So if I have I, I'll have minus I plus 1. Correct? Plus